protons or the carbons are present in my compound. Okay. So for that, I can use the NMR spectroscopy. See, there is a 1H NMR spectroscopy. There is a C13 NMR spectroscopy. So 1H NMR spectroscopy, in that you will come to know how many types of protons are present in your molecule. And C13, by using C13, you will get to know that how many types of carbons are present in that molecule. So these are different types of spectroscopy. So these are used to for the confirmation of your product. Like you are getting, I will write the reaction like after adding this, I'm getting this structure, okay, structure of the molecule. But how I will confirm that? So for that, these are techniques are used for that. So at the end, see the mass spectroscopy after doing the that 1H NMR C13, okay, I will come to know that how many types of protons are there, how many types of carbons are there. So from that, I will draw the structure like carbon hydrogen, how many carbon hydrogens are present. Okay, by using UV visible, I will come to know that double bond is there or not. Then also the nature of the carbonyl group. Okay, then IR spectroscopy. See, another IR spectroscopy. You use it for the functional group identification. Like by using that IR spectroscopy, you once comes to know that which functional groups are present in your molecule. So the IR spectroscopy is used for the functional group identification. Then after that, there is a after see functional groups, then carbon, hydrogens present. Okay, after that, normally the mass spectroscopy is done. Like in the mass spectroscopy, that molecule gets fragmented, and there is a various peaks you got, like a base peak is there, molecular ion peak is there. So it is for the confirmation of that. At the end, we normally do the mass spectroscopy. That is for the confirmation of our structure, like whether I got the right structure or not. So mass spectroscopy, in that, the basic theory, what is the basic theory? In that, the organic molecules are bombarded with the high energy electron beam. Energy electron beam. So the energy of these electrons, see, is typically about 70 electron volt. That is about 1600 kilocalorie per mole. Okay, and which is far excess of the usual chemical bond energies in the organic molecules. तो ऑर्गेनिक मॉलिक्यूल्स जो होते हैं उसके बॉन्ड ब्रेकिंग के लिए जो नॉर्मल एनर्जी चाहिए होती है उससे वो ज्यादा होती है ये एनर्जी. नॉर्मली द एनर्जी ऑफ द इलेक्ट्रॉन्स, it is 70 electron volt. So it comes in the like 1600 kilocalorie. In the kilocalorie, it's 1600 kilocalorie per mole. So which is a far higher. It is excess. So that's why normally 70 electron volt energy is used. Okay, because in that the bond will get break, and then the molecules get energized. Means energized means they break into the ions. Okay, they get ionized, and then there is a extensive fragmentation. And these fragments, these fragments are mostly positive ions, of each of which has a particular mass to charge ratio, that is m by e. after bombardment of that organic molecule with the electrons, it gets converted into the highly energetic positively charged ions. So these are called the molecular ions or the parent ions. And further, they break into the smaller ions, like fragment ions or the daughter ions. Okay? And see, the most of the ions have the unit charge, and hence that mass to charge ratio is simply the mass of the ion. Okay, so that mass to charge ratio, that is the mass of that ion. And then these ions are then analyzed such that the each value of that mass to charge ratio, okay, it gives the signal, means you will get the graph. So that peak in that graph, it denotes that mass to charge ratio of that for that particular ion. So the various ionic fragments are then separated according to their mass to charge ratio, okay, by deflection in the variable magnetic field. And then they generate the ion current at the collector in the proportion to their relative abundance. And then these signals will have the different intensities. Intensity means one signal, it will be very sharp and very long. Then the other peak, okay, other peak, it will be very short. Okay, so like this, it depends on the intensity, different intensities, which reflect the relative abundance of the ion producing the signal. So, basic principle of mass spectroscopy in that the organic molecules are bombarded with the electrons that are the high energy electrons. Okay, so that energy is 70 electron volt. So that is enough to break the chemical bond. Actually, it is far excess, okay, of the usual chemical bond energies. Then after that, then it is converted into the highly energetic positively charged ions, which are called molecular ions or the parent ions. And then it is further break into the smaller ions that are the fragment ions or the daughter ions. And then these ions formed then get separated by deflection in the magnetic field according to their mass and the charge. And you will get the mass spectrum, that is the graph. Now see the nature of the mass spectrum. Now such type of graph, mass spectrum, okay, it is a mass spectrum. So such type of graph you get. See now plot of the plot of a plot showing the relative intensities of the signals at different mass to charge ratio value is called a mass spectrum. And see, in that mass spectrum, the largest peak, okay, it is called the base peak. It's called the base peak. And see the molecular importance of the molecular ion peak. So, due to the impact of the electron, the neutral molecule, see, there is a M. It is a neutral molecule. So when electron beam, okay, it is bombarded with the electron beam, then that neutral molecule loses an electron, okay, and it gets converted into the radial cation. See the M plus, that is the cation, M plus, that is the cation, and the radial, okay, one with the one electron. So it forms the radial cation plus the two electrons are released. So this is called. the parent ion or the molecular ion, usually written as a M plus. So, during the formation of the molecular ion, the electron of lowest ionization potential is removed. Now, what is mean by that? The electron of lowest ionization potential is removed. See, molecule, in the molecule, you know there is a nucleus. In that there are protons, neutrons, okay, and the electrons are revolving around the nucleus. Now, uh, as the electrons which are near to the nucleus, which are revolving near to the nucleus, okay, so the energy required to remove that electrons will be required, it is high, okay, the energy which is required to remove that electrons, that will be high because they are near the nucleus, okay, they are quite not loosely held, okay, they are slightly uh, tightly held, okay, they are, and as you go away from the nucleus, the electrons revolving away from the nucleus, okay, in the outer orbitals, okay, so these are loosely held electrons, so you can the ionization potential is the energy required to remove an electron from the outermost shell of an atom. It is the ionization potential. What is the ionization potential? So it is the energy required to remove an electron from the outermost shell of the atom. So see what is written here during the formation of molecular ion, the electron of lowest ionization potential. अभी लोवेस्ट आयनाइजेशन पोटेंशियल किसका होगा कि जो इलेक्ट्रॉन को वेरी लेस एनर्जी लगेगी टू रिमूव द इलेक्ट्रॉन, ओके, दैट विल बी द okay. What is the ionization potential? The energy required to remove an electron from the outermost shell. So the electron of the lowest ionization potential will be removed during the formation of molecular ion, and the energy required to remove the electron, okay, it depends on the type of the electron, that is the lone pair, then there are conjugated pi bonds, then non-conjugated pi bonds, then there are sigma bonds. Now as you know, the sigma bond, it is a strong bond, it is formed by the horizontal overlap, okay, so there is a maximum overlap is there. You know the p orbitals, they are dumbbell shaped, okay, so see, sigma bond, it is formed by the horizontal overlap, so it is a strong bond as compared to the pi bonds, because pi bonds, they are formed by the lateral overlap. So see, you can see the energy, sigma electrons, okay, it requires the higher energy. Then comes the non-conjugated pi electrons. Then after that comes the conjugated pi electrons. And then comes the lone pair electrons. So likewise, there is a decrease in the energy. Okay, lone pairs will require the least energy to remove these electrons. Okay, lone pair electrons are easily removed. But for the sigma electrons, it requires the higher energy. And that molecular ion represents the unfragmented molecule. Okay, the molecular ion, what, why? Because from the neutral molecule, only the one electron is uh, the neutral ion losing only one electron. See, and it forms the radial cation, that is M plus. So that molecular ion represents the unfragmented molecule. and hence it has the same mass as the original molecule. And hence the location of the molecular ion peak is very important. Now see, this is the mass spectrum. You can see there is a relative intensity, relative abundance versus the mass to charge ratio, which is represented by m by z. So you can see the various peaks are there. Now this particular mass spectrum. It is for the 1, 2, 3, 4, 5. There is a molecule given over there. It is the long chain aliphatic compound only. It is a pentane and pentane. So in that you can see the molecular ion. See, it is 72. So it gives the molecular mass of the compound, molecular ion, 72 that is. And then there is a, see, what is the base importance of base peak? So base is, it is the highest peak in the mass spectrum. It is called the base peak. So you can see the base peak, the highest one, that is 43. It's written over here 43. Okay, and see, the base peak is the fragment in the greatest abundance. So its intensity is taken as 100, and the intensities of the other peaks are expressed relative to it. Means normally in the mass spectrum, the highest peak, okay, it is the base peak, and its intensity we take as a normally it is taken as a 100, and it is, and the other peaks intensities are expressed relative to it. Okay, so mass spectrum, in that there is a important, like there is a base peak is important, and then there molecular ion peak is also